And welcome to the Physical Chemical Changes and Physical and Chemical Properties video. When we talk about physical versus chemical changes, a physical change is one in which the identity of the matter is actually the same. The same atoms are attached to one another. I find that a lot of times physical changes are defined to students as changes that are always reversible. Tearing a paper into a bunch of tiny pieces is not reversible. You can't tape them together, but they won't just go back together. However, the chemical makeup of that paper is exactly the same stuff. You only physically altered it. Whereas in a chemical change, you're actually changing what atoms are bonded together. So if you burn a fuel, for example, if you think about burning that piece of paper you ripped up, what you're actually doing is taking the carbon in that paper and reacting with oxygen and making carbon dioxide and water vapor. Those are two actual different compounds with different formulas. So you have actually broken bonds and rearranged things. When we talk about the matter being recovered, when we say the original matter can be recovered, we just mean that without doing any sort of chemistry, we still have the same stuff there bonded together. A nice example here is when you mix salt into water, you can easily separate that salt out by evaporating or boiling away the water. When you react salt with something, so you can actually react salt with other compounds, if you rearrange who's bonded to who, you're no longer going to be able to recover that matter without doing another chemical change. And this is, combustion is another great example here. When you burn a fuel, such as gasoline or a piece of wood or paper, the carbon dioxide and water vapor goes into the atmosphere, and that's where it goes from there. It does not just turn back into that initial carbon fuel or oxygen gas. When we have a physical change, we are not able to write new chemical formulas, whereas in a chemical change, because bonds have been broken and reformed, or new bonds have been formed, new chemical formulas are able to be written. So we should be able to identify whether or not something is a physical or a chemical change. If you have butter melting on warm toast, that is a physical change. If butter is simply melting, you could, cool that butter down and it would become solid butter again. Lighting a match is actually a chemical change. So you're actually, burning that match as fuel, turning it into different stuff. The cooking of pancakes, generally when we cook most things, they turn into new compounds. If you simply boil water, however, it's H2O is a liquid, then H2O is a gas. You're just turning it into a different phase of matter, so that's going to be a physical change. Tarnished silver, and this is, a process that happens with silver. It's not unlike the rusting of iron in some ways. So this is a reaction between silver and sulfur in the atmosphere. And if you've ever seen tarnished silver, it kind of has that like orangish, kind of brownish coating on it. Freezing a popsicle, simply a physical change. All we're doing is taking a liquid and turning it into a solid. Milk going bad is a chemical change due to the respiration of bacteria that's inside of that milk. These relate to chemical and physical properties. So when we talk about a physical change, when we talk about a physical property, this is something that typically can be observed by doing simply a physical change, not necessarily a chemical change. So a great example of a physical property is melting point. So if we want to determine melting point, we do a physical change, which is melting. Some physical properties, such as color, can be observed just by looking at something. Whether or not something soluble or dissolves is a physical property, so we could check if something dissolves in water by dissolving some of it in water. Chemical properties require you to actually do some chemistry to test them, and these are properties relating to how well or how something might react with something else. So iron is actually something that rusts when it reacts with oxygen. So the fact that iron reacts with oxygen is considered a chemical property. Something being inert or unreactive, so helium is a noble gas, it is inert, it does not react very easily. Being inert or unreactive is a chemical property, so not being reactive is a chemical property as well as being reactive. So if we want to look at some properties and classify them, if we mass a copper wire, it's a simple physical property. Boiling something, so you know what temperature something boils at, physical property. If you make a Brady Bunch volcano, baking soda and vinegar reacts to make carbon dioxide gas. You have to do a chemical change to see that reaction occur. Solubility of sodium chloride water is 40 grams per 100 milliliters of water. How much salt dissolves in water? Solubility is a chemical property. I apologize for my misspelling of density. The density of mercury is 13.6 grams per milliliter. This is a physical property based on your mass and volume of the sample. There are two different types of physical properties that we need to be able to classify: extensive versus intensive physical properties. Extensive properties are properties that depend on how much of the sample you have. So if I wanted to measure the amount of energy being contained in a certain sample, if I have a large sample of gasoline, the amount of energy being stored there is much greater than if I have a small sample of gasoline. Mass is obviously very much based on size or how much you have of a sample. Heat, a small fire is going to give off less heat than a big fire. Intensive properties do not depend on the amount. These can often be used also to identify matter, although that's not 100% true. So boiling point, if you wanted to boil 1 milliliter of water, you need to get it to 100 degrees Celsius. If you want to boil 1,000 milliliters of water, you need to get it to 100 degrees Celsius. So that actual boiling point is the same. Now the amount of heat is different, but the actual temperature that we have to get to is the same. Color, if you take a big piece of copper and you chop it down, it remains the same color. Density, because it's grams related to milliliters, because the relationship of those two quantities makes that intensive. The density of water is always 1 gram per milliliter, no matter how much you have. And the temperature of a sample is actually intensive as well. If I had some water that was 35 degrees Celsius and I poured some of it in another container, it would still remain 35 degrees Celsius, even though there's less water there. That temperature actually stays the same. So I'm going to go back to the previous slide and identify which of these physical properties are extensive and intensive. So the mass of my copper wire, because this is mass, the amount really depends, that's an extensive property. Boiling point, no matter how much of the ethyl alcohol you have, boiling point remains the same. That is an intensive physical property. Solubility is kind of a weird one because you're like, well, it's amount. It's talking about 40 grams, but this is actually intensive. So this is actually talking about ability to dissolve, which is inherent to a substance. And density is always an intensive property that's actually used really well in identifying different samples. So one more thing I do want to mention in terms of identifying, if we look back at these extensive properties, boiling point is a great one for identifying a substance. If you have two things that look alike, maybe boil one, boil the other, see what temperature that happens at. Density, really good for identifying. And color and temperature, not necessarily kind of on their own. A lot of things can be the same color. A lot of different samples can be the same temperature. However, if you measure the temperature that something boils at, it becomes a different deal. So important understanding which of these can be used as identification, which of these are extensive or intensive. So if something boils at 67 degrees Celsius, this is intensive and can be used to ID something. 5.6 grams per milliliter, G per milliliter, that's mass per volume. This is intensive because it is talking about density, and that can also be used to ID something. Something being 2 milliliters long is extensive, that's just talking about its size, so that's not really useful in identifying a sample on its own. A sample being 45 degrees Celsius is intensive, but not particularly useful on its own in identifying a substance. If you're saying it was boiling at 45, that'd be different. Volume, so just plain milliliters, is extensive. If you pick up a sample of rust, it's going to be orange. That is intensive. That on its own, not really necessarily enough for identification. So, the color might be kind of characteristic, but you might need to figure out something else to make sure that you're actually looking at rust for sure. Grams is mass, that's extensive. And if you think back to earth science, you talk about that Mohs hardness scale. The hardness scale is an intensive property. Diamond is hard no matter how much of it you have. And this can often be used in identification, not 100% of the time, but obviously it was something that's used in identifying rocks back in earth science. And certain substances do have very characteristic hardnesses or not hardnesses. Some are very soft, which can be used in identification.